third integral representation for Digamma function. So basically I'm doing a series where I'm just deriving all the representation of Digamma function in terms of integral. And the first one was the well-known one, a negative of Macedonian constant plus integral from 0 to 1 t to the power g minus 1 by 1 minus t to the power g minus 1 by 1 minus t dt. And the second one was integral from 0 to 1 of negative 1 by ln t minus t to the power g minus 1 by 1 minus t dt. We have derived these two formulas already. Yeah. Now in this video, I will use the second one to prove this. And if you want to know how to derive this one, please check the video over here. Okay. Now let's start with the second one and derive this third representation. Integral from 0 to 1 minus 1 by ln of t minus t to the power z minus 1 by 1 minus t dt. Now let's make a substitution. Yeah. Okay, so basically let's try to change these limits from 0 to infinity. So for that, you need to have y equals to minus ln t, such that this goes to infinity and this goes to 0. And that gives us t equals to e to the power minus y. Yeah. So we have an integral going from infinity to 0. This is minus 1 by this is minus y, and then minus this is e to the power minus y times g minus 1 by this is 1 minus e to the power minus y, and dt is also minus e to the power minus y dy. Yeah. And now after this, what do we get? We can use the negative sign to reflect the integral, so that it goes from 0 to infinity, and this is just 1 by y. Yeah, minus this is e to the power minus yg times e to the power y. This is g. Yeah, don't see all the okay, it is by 1 minus e to the power minus y times e to the power minus y dy. Okay, now you can multiply by e to the power minus y, and that gives integral from 0 to infinity e to the power minus y by y minus this is e to the power minus yg by 1 minus e to the power minus y dy. Yeah. Now if I write in terms of t, we will have integral from 0 to infinity, yeah, e to the power minus t by t minus e to the power minus gt by 1 minus e to the power minus t dt. So this is the diagram of g, and yeah, we derived the formula. So basically, because we had this formula already in our hand, it wasn't that tough. But to derive this formula, I hope you have checked the video that I linked here earlier. It's also in my playlist of Digamma function. Thanks for watching. Look forward to seeing you in the upcoming video.